Hello, everyone, and good time of the day to you. My name is Quintessence, and I'll be guest hosting this week's Contributing Today meetup. I'm currently a developer advocate at PagerDuty, which means that I'm mostly focused in process and incident response. But I do have a background in engineering and do have some experience with chaos. Also, let's listen a little bit more about Contributing Today, which is a weekly show covering a different open source tech topic every week. Maybe you're a regular, maybe you're joining for just this week's topic, which is chaos engineering. Either way, let friends and strangers on the internet know that you're watching this meetup by using the hashtag Contributing Today on Twitter or your social media of choice. And joining us in the chat, either in Discord, here on Discord, or in the embedded chat to the right of this room. Spoiler, it's the same. And when you do join, please be mindful of our code of conduct. You can review our terms here via contributing.today/code-of-conduct. You can find recordings of past meetups like Python, Go, writing docs, funding, and sponsoring via contributing.today/past-sessions. All right, let's get started. We're doing a bit of a panel free flow discussion today with folks from the chaos engineering world. So let's start introducing them. So we have Jason Yee, who is the Director of Advocacy at Gremlin, formerly of Datadog, O'Reilly, and MongoDB. He's a serial conference organizer and speaker. We also have Arnold van Wijnbergen, observability advocate and consultancy firm Full Stack with a Q, working for customers like Albert Heijn as PO SRE Observability and Platform. And if you watched last week's episode, you would have heard from two of his colleagues. We also have Alish Plishik, Senior Software Engineer at Netflix, formerly of Apple, Up There, and Oracle. So let's level set first and talk about what chaos engineering is. So who wants to take the lead on defining chaos engineering for our listeners?
Let's start. Yeah. Let's start with chaos engineering. If you never heard about it, chaos engineering is really about checking. It's the discipline of testing the resiliency of your systems, mostly the distributed systems, with one goal, is to minimize and improve your resiliency. So, how do you think about it, Jason?
Yeah, I was going to say, so my understanding of chaos engineering has evolved over the past few years as I've practiced it. And that was like what you said was exactly my definition, right? It's testing your systems to make them better. And I think over time, what I've realized, especially with complex systems, is that the biggest gap that we have with complex systems is our understanding of them and how they operate. Simply because everything's distributed, everything's broken down into multiple services, whether or not you're using microservices. So these days, I like to say that chaos engineering really is a process of just understanding and learning more, finding unknown unknowns and just validating your mental model.
Yeah, I would second that, James, and I think this is a great definition. For us, it's also about experimentation and how to use this experimentation to uncover these hidden vulnerabilities in your system, and how to gain knowledge about your system and about what can break and how it breaks. So that's about it, I would say.
Yeah, and it's the same for us here too. We have experiment driven, so we're trying to say, oh, how does the system behave under these circumstances, either unforeseen or potentially hindsight seen, and just getting a better view of what's happening. And speaking of, what was everyone's introduction to chaos engineering? The first time you heard about it, the first experiment you ran, even.
Yeah,
don't all jump in at once.
I heard about chaos engineering pretty early on, but I had not actually done it. So I worked at O'Reilly, as you mentioned in my intro, and my job at O'Reilly was to help run the Velocity Conference, which is where I think a lot of these ideas that we have in DevOps now that are normal were first introduced. And so that's kind of one of the first big stages that Netflix came on and said that they were doing this thing. But it wasn't until I joined Datadog that we actually started doing it and that I'd actually got my hands into it.
Yeah, I actually like my foray into it because when I first heard about it, I didn't hear about it by name. And it took like a couple of years after when I did hear about it by name that I kind of went, oh, right. So I was working at an unnamed company that had a very massive production outage. And when I say massive, I mean several days. And at some point after that, my then manager had gone to a conference, came back, and was like, we were talking about taking our production systems on purpose. And having that lived experience so close to her having that experience, our team was like, yes. Because one of the reasons it took us so long to recover was like certain amounts of knowledge had been lost or whatever. So it kept, going down and up again and whatever. We got it resolved. But then we were like, yes, we should definitely do this on purpose so that we we map this out and never have this happen again. So we were all maybe a little too excited, but yeah.
Yeah. That's great. Yeah, I've started in 2015 with, let's say, Simian Army, and we went out with Chaos Monkey at 2015, and it was at ING Bank. So I was a monitoring lead for, let's say, a big project, and we want to be more proactive. And in that, we couldn't run it on production, but we were, let's say, running randomly tests on the acceptance environments on the VMware layer, and that really helped. Teams really got some insights because they came back to the office morning. They got some notification, but didn't know the exact moment. And then they saw the system was hit and it was not usable anymore. So they had to improve the reliability. And it was much better because normally you had a lot of costs involved as a big organization with these long-running programs. So that's really big.
Yeah, I was going to say, I love what you just said about you couldn't run it in production, but you still ran it, right? Because I don't know if people talk to you about that, but like that's one of the biggest questions that I get is, what if I can't do it in production? Like, does it have to be done in production? And simply the fact that like I work with a lot of banks similar to ING, and they're like, we cannot do this in production. But the idea of finding value in it, even in staging or development.
Yeah, and it's a culture thing. So you have to embrace failure. And if you look at management layers, they don't like failure when websites goes down because the revenue is directly a problem. You can hit your revenue, like with Albert Heijn. If we stop our website, orders are not flowing in anymore. That's not good. We got a lot of users, and the user experience is really important for us. The whole flow. So yeah, it's but you have to start, and it's also a learning process.
Yeah, definitely. Yeah. If Albert Heijn goes down and I can't get my groceries.
Yeah, grocery store, indeed.
But you can still watch Netflix, at least to pass the time. So I think when we are down, everyone knows. So, but we do similarly. I also started with Chaos Monkey, and we were shutting instances, and then we sort of promoted, and we would trip the whole racks in the data center in one of the startups where I was. So, but since then we moved on. When I joined Netflix, I think the practice moved on also in Netflix, where we don't shut down instances anymore, or not that it's not that something that would give us that much value these days. But we really try to do fine-grained chaos engineering, where we just inject faults into service communication, for example.
Yeah, and kind of piggybacking on that a little bit. So at PagerDuty, one of the things that we do is we have game days, right, or failure Fridays to run our experiments, right? And we use Gremlin. Transparently, we use Gremlin. But how do you all, when you're implementing chaos engineering at your various, employers, past employers, whatever, how did you implement that? What was successful or unsuccessful? Can learn a lot from that too.
Yeah. I mean, for me, one of the things when I joined Gremlin actually was the idea of dog fooding and actually doing chaos engineering. So, when you're interviewing with a company, you have one perception of it, or at least when you're outside a company, and when you join, you realize things are completely different. So when I first joined Gremlin, they had kind of stopped doing chaos engineering, which was interesting, or it was like very rarely done. So I think, for me, a lot of it was getting back in there and starting to rebuild that practice and just like, get people on board, remind them how fun it was to actually do and the value of doing that.
We also try to sort of sell chaos engineering, that we sort of redefine it, because each time you introduce any change into your production system, it's sort of a chaos, and you don't know how that would impact your customers. So any change that we do, we try to sort of give tools to our engineers that they can actually validate or measure the effect of this change. So.
Yeah, and it's also a little bit of an outcome, what you can validate them, because if you want to sell these things, it's what do you want? A resilient system, a flow that's continuing, customers that are happy, or do you want to have, for example, a big outage like what you told Contessa about that your system is down for several days or a week, it's not running. That's not good for your business, and it's really reactive because it's looking for a key, the golden key, to unlock it again, and that's not good. That's not how you run a business. So how do you sell it? It's really the loss, the profit loss, what you can have, and let's say how do you call it, the damage, your reputation of a bank, but also the grocery like Albert Heijn, shopping, online shopping, very important, because next time they go to another, for example, eBay, to buy their stuff.
Yeah, and I think that in terms of getting that exec buy-in, sometimes a little bit of this is the scary place, like you're talking about, is very useful. But there's also a certain amount of use to just kind of explaining some of the logistics of, well, it took us so long to respond to an incident because we successfully have rare incidents, for an example, right? So it took us so long because we're out of practice, and the only way to have practice, right, is to manufacture practice. And you can get, if you can show some of the things that you're trying to reduce or get better at, as in addition to saying, we don't want these long outages and reputation damage and et cetera, but in order to improve those times, we can respond after if we test the following. We noticed we had a weakness here. Let's design an experiment to combat that. And if you start presenting it that way, you might get a little bit of, oh, that's why you want to do this. Mm-hmm. Yeah. Did anyone else want to chime in on that? All right, since not, let's talk about, for a person who wants to learn more and get started with gas engineering, where do you start? What resources do you recommend? Are there community resources, things like that?
Yeah. So I've started, let's say, on the internet, reading things. I've joined the Google community of the Chaos engineering community on Google. This really helped me. In the beginning, in 2017, I had contact with the maintainers and the builders of Chaos Toolkit. So this really helped me to understand the principles and implementing it, because it's not about the tool, it's about the way that you steer your tool, the ID, the hypothesis that you have, and understand what is your steady state of your system. So this really helped me.
And what really helped me is trying to get something that was, I'll say, a consumable length for just context setting, because before you're doing the deep dive into some of the more like logistics or why, you need to kind of understand some of the context. And for that, it really helps when companies that have technical blogs, so tech companies, right? New Relic, Datadog, DigitalOcean, whomever, right? All of their technical blogs are very technical. And so when they do a write-up of, hey, this is how we got started with chaos engineering, for example, that can be really helpful because they're talking about like their lived experience as team or teams doing these practices.
Yeah. I think the great resource is also, sorry, Jason, the incident reports that you mentioned that are usually published on these tech blogs, where you can really see what was the sort of how the incident evolved and what were the triggering patterns and how it could be prevented. So those are great example. Something went wrong and how can we prevent it? It will never happen again.
And I think that's a great place to start off too, is, people ask, what experiment should I run as I'm getting started? And I think replaying some of those, as you look at like Slack had the major outage right at the new year, right? And that was all about provisioning, and their provisioner went down. They couldn't auto scale. So things like that are great places to start. In addition to the Google group that the link is on screen right now, there's also the Chaos Engineering Slack, and that's something that Gremlin hosts. So you can get there at gremlin.com/community. Although we host it, we pay the bill for it, but it isn't specific to Gremlin. So, Russ and the folks from Chaos IQ /Chaos Toolkit are on there. I think some of the folks from Verica are on there. There's a bunch of people just involved. So it's a really nice place if you want a bit more of that, synchronous dialogue.
And one of the other things, I'm going to kind of segue into the next question too about this. When you're getting started, it helps with, if you're like, oh, how do I do this on the ground here, to not do it in production first. You need to get a little meta about it, right? So you need to have your own either pre-prod or sandbox or something so that you can get used to whatever tools you plan to run your experiment with. Because until you're proficient with what you're doing chaos engineering with, you're not going to have a good time, doing it directly in production on its first go, which kind of ties into the question we have about, isn't it unsafe actually to test in production?
Yeah, well, I mean, the funny thing though is you say that as if it's something new, and people think, like, how do I do this? I'm like, how do you develop code? Do you just like write code? Like, let's SSH into a prod box and write some code and then like it's there? Like, no, of course, like you work in development and you push that to like testing, and like, why would you think any of this would be any different from that?
Yeah, that's true. And there are other techniques which you can use. You can combine it with, let's say, progressive delivery. So blue-green canary deployments. So this is a way how you can use it in a way, because then you reroute traffic to a certain, or the JSON to a certain part of your application. But that's really also when you are more mature, when you are really understanding your application, your chain, and like what they do at Netflix. What I really like is they're growing up the chain. So they're now, I think, I'm really curious about it. So about it's not only the service, it's not infra anymore. It's injecting maybe business failure like of things, queues, messages that go wrong. And this is another level. I think this is, you can aim for it, but it takes a time to go there.
Yeah, but Arnold, I really like your point that you mentioned the canary deployments. I think that's really a nice introduction into experimentation. And I wanted to say that's like really the first step, even before you start chaos. Just to run canary deployments is a great way how to learn about your system and how to really, because canary deployment is in fact an experiment. And so that's a very valuable technique that you can learn and introduce into your organization to do that.
Yeah, we're already kind of segueing. Oh, sorry, go ahead.
I was going to say, what Alish said, the nice thing about that is you often get that question of, well, if I'm testing this out, but there's no traffic to it, how do I know, right? And so I think that's also where canary deployments come into play, where you can start directing at least a little bit of traffic to it and getting some sort of signal from that, and then you can release it to more and more people, because it's obviously going to be different than having no traffic or using an artificial load generator or things like that.
Yeah, and that kind of segues rather into our next question, which is, the designing of chaos experiments. How do you design a chaos experiment? How do you discover via technology or other means, what areas of your application infrastructure, environment in general can be chaosed, so to speak, or experimented on?
Yeah,
so
well,
go ahead, Jason.
I think a lot of it, depending on what tool you're using, a lot of it just tends to be like, what's your understanding of the system and figuring that out. Like chaos engineering is a good way to figure out what other services are, for example, dependent on your service. When you kill that service and a bunch of other things go down, then you kind of know, right, who complains or what alerts get thrown. I should say that Gremlin, we just literally yesterday released a new feature that's service discovery. So thanks for asking that question, but we have rolled that into our product now. So it actually will look at and try to find all the services that you've got and expose them as things that can be tested.
Yeah, it's really about understanding what is the steady state and what are things in your cloud environment. Do you have multiple regions? Do you use multiple availability zones? Do you have some kind of database rollover mechanism that you can trigger, which can fail? All the things that you can discover, like what can be the moment of, let's say, that we have to do some kind of DR moment. Please check these things, do experiments on them, all these failure things, look for these hypotheses, and then apply them to your tooling. And after that, you always find things at other levels, like your queuing mechanisms or your application, or even business failures, because I think that's are the nicest things. Like when I've worked on another company, we were injecting business errors, like I cannot tell much about it, but we were injecting wrong value rates and large amounts of traffic to the network there. And that also gave funny results sometimes, because that customer was, let's say, a big low latency network provider for like big companies. And it was really nice to see the network guys really say, whoa, I didn't know that was going to happen. So
yeah.
Mm-hmm. Interesting. So at Netflix, really, our resilience engineering team, we don't really try to run any experiments. We just want to offer the tools so that the actual service owners can run these experiments, because they have the best knowledge about how the service works and where it can break. And we are just trying to automate the experiment for them so that it's safe, so we can shut down the experiment as soon as we detect any impact to the service or the customers. So really, our goal is just to really make it as easy as possible for them to run these experiments, and hopefully they will adapt and adopt these techniques. So that's also, and the way how we also, our guidance is that you always need to like construct very carefully the hypothesis of what you are testing and how you are testing it, and what can go wrong and how you monitor it. So that's really, so there should be a real enough work done before you actually run the experiment. So then.
And when you all are setting up various chaos experiments or trying to get buy-in so that people, not the exec level, but just, the ICs, the contributors, to get them to run experiments, what do you think is most successful in making it relatively easier, straightforward to get things done? So that they're actually running the experiments.
Yeah. They need to feel safe. They need to feel safe that, because they are often worried that they will actually shut down Netflix, or they will, that would be really not beneficial. But so they need to really feel safe that they can run this experiment, and we will monitor it, and we'll very quickly shut down if there is any impact. So I think that's usually the hardest thing to do for them, to cross that bridge. But once they do it, maybe we assist them once or twice. So once they get into that practice, they will very quickly adopt it, because they are responsible for that service. So they don't want to be paged in the middle of the night. So for them, it's better to just run those experiments during the day and make sure that everything is stable. So
yeah, it's all about confidence and getting people that they see the benefits of it, and they indeed see like, we're now getting more proactive, and normally we have to do these testing, let's say, once a period, and still we have these issues. Business is coming to us, but now they have this in an automated way. It's, let's say, shift left part. And that's also important thing, what I see. It's also a little bit merging with performance testing, because that's also important. But nowadays, performance is also getting more and more important, not only from ops and not only when going into production, but also when you are in production. What is your performance? And how is your system responding on that when you have attacks? It's also interesting.
Yeah, I think there's definitely, as mentioned, having that safety and that feeling that it's okay. But back to my comment earlier about like, how do you convince people? The fact is it's actually fun to do, right? Like once you start doing this, the idea of let's see if I can blow up my service, like, or what it would take. And like, I don't know, there's just something fun about it. And there's different ways that you can structure it. But one of the more fun ways that I find people really like is when you have like somebody secretly doing attack and like, everybody knows something's going to happen, but you don't know what, right? And so it's this game of like, can you see what I'm doing? Can you identify it? Can you use all of your tools to try to figure this out? It just becomes one of those like puzzles that naturally gets people engaged.
Yeah, and before we go to our next question, just to hang on to psychological safety for a minute here, when we're talking about how you actually create the safety, so there's the direct speaking, right, where you can say, oh, I would like it if you're a management or someone in decision making position, I would like it if you ran these experiments. But realistically, though, there is a fear, right? I mean, Alice, you said it when you're like, someone's afraid they're going to take down Netflix or whatever the production service is. So how do you really instill confidence that the safety is actually there, not just, do as I say, not as I do type situation?
Well, I think everyone see the benefit because you want to prevent these incidents actually happening because we see the impacts of these incidents. Because if we miss something or if there are always incidents happening. So usually also what is happening is that there's an incident and the service owner resolves the incident, but they come back to us and they say, how can I reproduce this as an experiment that will run every month? So I not only can fix this, but that I make sure that I regularly validate that I'm resilient towards these kinds of incidents. So I think that's that's maybe one of the motivating factors there. And yeah, and of course it's important from the leadership to acknowledge that these experiments are valid and beneficial. I think that's that of course that needs to be there. But at Netflix, our culture specifically says that we are responsible. The engineers themselves are responsible for the service and for the service being available, and also for all the technical decisions. So if they decide that chaos engineering is the method to use, so then they have a green light to do that because they are the ultimate owners of that decision.
Yeah. So postmortems, let's say the outcome of a postmortem is also very helpful for that.
Mm-hmm.
As, let's say, an input for an experiment, what you explained, like in the old days, you improved your monitoring on that when you had a big outage. But now it's already including, again, going back to the testing part, make an experiment out of it. What went wrong? And validate this in your acceptance or production deployments. So that's also a way how you can tie it in the way of working.
Yeah, I mean, I think as you asked that question about safety, it really comes. Eilish said a bunch of things earlier, right? Previous questions, canary deployments. We talked about doing it in development and building up the practice till you get to production. Eilish mentioned abort conditions, right? The idea of you have to have a predefined limit of if this thing happens and it goes wrong, what does that wrong look like for us to stop it? And the idea of being able to spot that and know that it's happening and stopping it quickly means that it's not going to really affect your customers, right? So I think there's all of these things together provide that safety.
Yeah, for sure. And going into the questions that we're getting, since we're getting a couple, would you recommend to always include chaos engineering as part of the software delivery process? I mean, I'm going to say yes, but your mileage may vary on exactly how often or what that means, right? I don't know if you all have different thoughts or you want to add to that one.
I would definitely include. So for us, it moves or it shifted or evolved that not only chaos engineering, but resilience engineering. So we just run these experiments. And it doesn't have to be fault injection. It can be, a canary which just evaluates a new version of your code, or a data canary where we just evaluate some data file change. How does that impact our customers? So I think those are definitely these validating integration tests and validating methods are really important. I think they need to be included into the software development lifecycle.
And the next question is, what happens after an experiment? So are there rituals like Scrum? So I'll say that at PagerDuty, when we're running our chaos experiments, we usually always make sure that the experiment is resolved right before running another one. We run it kind of like a minified incident, which it is. So we respond to it the way we would as an incident. We do a post-mortem of sorts for it, right? So you analyze what actually happened versus what was expected to happen and so on. But how do you all, when you're running experiments and you're in that resolution phase?
We do the same, handle it sort of like an incident, run a retrospective on it. And then I'd also add celebrate after.
Oh, yeah.
Make it a fun thing. So go get some beers or something.
Yeah.
Yeah, and indeed, mentioning also the game days, which are also important. Game days to execute these experiments, to test with your teams and look what can be improved, and indeed celebrate and do a retro, because you will really have to learn and from your findings and loop them back and before you trap in it again.
Yeah, I think that's really important, because one of the findings can be that you run an experiment and you actually cause an impact. And then the learning from that is, oh, this is a really essential dependency that we cannot just fail. So then that's also a valuable outcome of an experiment. And usually the acting on top of that knowledge is that you maybe pre-scale or you harden that service or that key dependency that you have. So you really uncovered some hidden vulnerability, and you need to really take care of that, and because it's a critical dependency. So that's also, it's important to celebrate the outages too, or so if you don't find any impacts and just everything goes as expected, that's also important moment to celebrate. Yeah,
I like that, capturing like new items. I don't think I've ever run an experiment or a game day where even when things went exactly as expected, like there was always still more. And so that's a big thing we've started incorporating, is like suggest an experiment for the next group or for yourself the next time, because there's always like at least one, but often like a handful of like, oh, we didn't dive into this, or we didn't look at this. Yeah. We should do that next time.
Oh, yeah. We thought this was still running then, but instead, we had some retries and they're all finished and now it's gone. So these are all the things that you forget, which can pop up.
Yeah.
Awesome. And the next question is a little bit of a pivot. And I'll admit, I have no idea. It would make sense to me if so. Companies that practice chaos engineering, are they more bold in other areas as well, like marketing-wise? So I guess, are they more risk-taking is how I interpret that question. And it would seem to me that, like, yes, but with the type of risk-taking that comes with doing a litmus test, right? That's kind of what chaos engineering is.
Yeah.
But I don't know.
Yeah, risk with confidence, I think. That's for me when I think about it, because you need to be confident. So you do testing, you do chaos testing, that makes you confident. And if a team, if you are a DevOps team and you know your solution, you know it by heart, you tested it on several layers, and you do blue-green deployments, then you have more benefits from, and more certain to deploy it in a good state. So, and then you're also, as a team, you're getting more and more happy and getting more and better improving this service. So in the end, yes, it will help for the business, but also for the team. That's also important.
Yeah.
Yeah, true. I believe it's a controlled experiment, and you want to invest in certain area, and then you want to limit the blast radius of that experiment, and you want to validate and measure that impact, and that not only can be applied. This approach can be applied not only in chaos engineering, but in almost any field or any venture, let's say.
Yeah. And our next question is, do you typically communicate, and they're talking about publicly communicate about root cause analysis when things go wrong as a result of a chaos experiment. And I'll just take a little tangent about root cause because I have to. It's hard to say root cause, right? Because it's not always by itself, it probably wouldn't have caused a failure, right? There's usually smaller, tolerable failures that happened or were sustainable or that you were more resilient to in other situations, that it didn't cause a failure, but it caused a failure this time because as part of the experiment, you were overloading the network or whatever you were doing. Like the combination of factors is what caused the failure. And I would say that for us, we don't really communicate unless there's some interesting finding that we want to read a technical blog about, right? I don't know about y'all, but that's usually how we do it.
Yeah, in my career, I've never experienced where a chaos engineering test has significantly impacted production and taken it down simply because we've practiced up until that point. And generally, if something major did happen, we stop the experiment, we roll things back, and very few people notice. That said, I'm all for like publicly publishing incident retrospectives when you can. We don't always do it, but if you can, they're useful for the community.
Yeah. Especially when I look at it, I never did, let's say, the chaos engineering, let's say, that it failed on production. But I also like the transparency. Just take the failure that GitLab had, I think, years ago, but they had a database outage. They were very transparent. I think they even had a chat open or a Slack channel, live stream, where they were maintaining the system. And you really could look into the process of troubleshooting. So that was really transparent. And that's what I like for an IT company, how they can work together. Because it can always happen, but you have to embrace that failure and fix it as fast as possible.
Yeah. I'm talking about failure and embracing failure and I guess tools, right? So we know Gremlin is a tool in this space. But, do any of y'all have thoughts on tools that you do use for your experiments? The only ones that I'm aware of that I would think of are kind of one-off tools. I would use this tool to attack my network. I would use this tool to mess with my database. I would use this tool, right? It's not a singular comprehensive tool. It's just a series of things that you do to disrupt a very specific, for whatever your experiment is. I don't know if y'all do it any differently.
Yeah, obviously at Gremlin, we dog food Gremlin, so that's what we use. When I was at Datadog, we used Chaos Toolkit, the open source. We didn't use any of the paid services. A lot of the stuff does rely on open source. So StressNG is a standard Linux tool that will eat up your CPU or memory or IO, things like that. StressNG is a fantastic way to get started. But if you do that, be very careful that you don't kill the system and lock yourself out. But yeah, there are easy ways to get started. You don't need to buy a tool. Tools just sometimes make it easier.
Yeah.
So we have an in-house grown tool, and we just try to consolidate everything under the same roof. So that it's easier for service owners to just go to one tool and run all they can just choose from different scenarios or experiment types that they can run. We use Kayenta heavily, which is a tool that you can use to compare or measure impact of your Canary deployment. So that one is open source actually, so that if you want to, you can use that. It works well with Spinnaker. So
yeah. For me, it was really depending on customers and also on the time when I've used it. So beginning, it was Chaos Monkey, but it had some learning curve. So that was also sometimes hard to implement it for a customer easily. So I've used Chaos Toolkit in the beginning with a lot of drivers for Kubernetes, for AWS. And indeed, you can also use TC, traffic control, where you can drain down your Linux network systems. Nowadays, when you look at Kubernetes, I also always look at the CNCF tools that are available, like Litmus and Chaos Mesh. I have some preferences there when it comes to Kubernetes.
Yeah. And kind of relevant to all of that, and pivoting a little bit into observability for a quick second, when you're running a chaos experiment, right, you need to kind of keep track of what it's doing and where and what alerts it's setting off. So how do you all manage your various monitoring platforms or any other platforms that you have integrated for visibility into your systems?
Yeah, for us, it's very important. The safe, that's the key part of the safety. So when we run the experiment, we really, that's the signal that is coming to us from our observability platforms, so that we can see if that experiment is actually causing any impact. And that's not only impact on client dependencies, but also we track all the member client devices that are actually part of the experiment. So we can also see what is the impact of this change or this experiment on our client users. Are they actually able to stream Netflix right now? And that's how we can sort of track this end to end. And that way, it's not only measuring some impact on some backend services, but also it's really end to end experience that we measure and track. So that's,
yeah.
Yeah, monitoring is an important part of it. So observability, because if something goes down and you don't see it in your monitoring, you also found out something else, that you don't have enough observability in place or monitoring. So this really helps. And yeah, we use, let's say, several tools for that, but indeed several customers, several tools, but logging metrics, but also traces, end-to-end synthetics, real user monitoring. This all helps.
Yep. Nothing to add. There's a ton of tools. I mean, I could say that we use Datadog, but like, working with customers, basically you need to have monitoring. You shouldn't be that opinionated. Like,
right.
If you've got monitoring, that's what you need. If you don't have monitoring, get that first.
Yeah.
Yeah. And I would just add to say, make sure you're practicing hygiene about it. So everyone's mentioned about, it might unveil things about how you have things configured. For example, you might be running an experiment and things don't fire because you don't have conditions for them, or the conditions are incorrect or whatever. So make sure you're practicing hygiene when you run experiments and adjust your monitoring to actually give you the information you expect in logging and other sorts, so that you actually see it, because something's happening because you're making an experiment. But if something were happening, organically, you would need those alerts to fire to know something's up.
I think I'd dovetail onto that and say, ensure that your alerts are like usable, like actionable alerts. Like, one of the problems that I've seen as I've helped customers with things is they'll be like, it's really easy in chaos engineering to say like consume CPU or consume memory and do these resource attacks. And so they'll be like, well, we should have an alert when I'm using 100% CPU. And it's like, well, yeah, obviously, if you do that, your chaos engineering is going to fire your alert and it seems fine, but that alert is not useful, right? Like, so validating that your alerts are useful things about like customer impact or services that are, impacted, more than just what you're doing in that chaos engineering experiment.
Yeah.
Right. And making sure that the body text is not so long that it's unreadable, but not so short that it doesn't have information. So for example, just to pick the same one, 100% CPU utilization, is there a specific process that's using up all your bandwidth? Right? And make sure that that's included in whatever is firing off.
Yeah, that's also a funny story. Yeah, it's a side story, but I had a customer that it was worked at one other employee, but we had a customer, had to come in, monitoring. It was not running anymore, the application, very slow. What was going on? The website was hacked and they didn't have any monitoring. So they came, we need monitoring. It was Bitcoin miners running on their web servers. So yeah, for that, they used the CPU, and that's why their application went so slow. So when I've removed everything, or that it was working again. So yeah, it can be helpful. CPU trending, capacity management, but also looking at the process, what is going on, because sometimes you don't want to see these things like backups that are running or database exports.
Yeah, kind of adding to that, because it reminded me of something that was funny. We actually, a few jobs ago, we also encountered a Bitcoin miner on our cluster. And it was interesting because the notification that fired was a process that seemed recognizable And it was only on second glance that it looked like it had a typo in it, which processes don't have typos, but like, but it wasn't immediately obvious until you did a double take, so to speak, on it and said, wait, I don't think that's actually the process name. And sure enough, there were two processes that were similarly named, and one was legit and one was the mining process.
Okay.
Yeah.
Can happen indeed.
For sure.
For monitoring, we also try to make sure that we monitor how many chaos experiments we are actually running in parallel, which is also important, because you don't want to run too much, or you don't want to dedicate too much of your traffic to chaos experiments because you're just increasing the risk. So that's also sort of a thing that you need to keep in mind.
Yeah.
Oh. Yeah.
Also, it looks like we have time for one more question before I know we have a couple of demos for people to look at tools of chaos. So last question, is chaos engineering mostly applied for infrastructure type validations, or would it also equally apply for injecting wrong data or corrupting any sort of application memory, things like that?
Yeah.
So I mentioned it already. So we are actually adding new test cases or new cases of experimentation where we, for example, canary different data models, or if you want to migrate to a new database, we also canary that your service is talking to this new database. So there's lots of chaos is not only the only thing that you can experiment on. And it's basically any change that is happening in your system can be an experiment. So that's very important. We do also performance tests in production. Yeah, so there's a lot of things.
Yeah, it's really important to grow. So I think to say that chaos engineering is infrastructure, I think there's where you start your journey. But over time, you will improve your skills, your capability, and it will be better and improved. And then you go from network application components to the middleware part, then to the application itself. And what I said, business logic, these are the nicest things to validate, because then business says, whoa, can you find out this for me? We never thought this was possible. So it's a little bit like hacking your environment and looking if it's still reliable.
Yeah.
Yeah, I'd say especially as more and more things move to the cloud and managed services, right? Like things on the business level is just something that's going to happen naturally. Because eventually, you run into companies that they're like, we don't have infrastructure. We're all Lambdas and, RDS and, messaging queues and things like that. And you're like, oh, I guess, yeah, where is the infrastructure? But it's pretty easy to start thinking about, okay, well, let's think about the network, the latency, and then let's think about like, what if they generate those weird messages or unstructured data, things like that. Yeah.
Yeah, and kind of to the malformed data type of thing, like it does make sense to have security testing as part of your chaos experiments. Make sure to work with your security teams. Don't just eat it into production. Yeah. I just feel like I really need to heavily caveat that recommendation. But yeah, if you're going to be doing certain types of security testing as an experiment, it's the same-ish as everything else, right? Scope it, protect, blast, and work with the experts to get it done.
Yeah, and indeed, the security availability is part of security. So, but they always type to put it away somewhere because, it's not the product itself. But nowadays, it becomes more and more the product availability. It's not only the office that needs to be open; it's more. So, it's really important to improve all these angles of security and availability, and take it serious as a company, as a risk.
All right, I know we have 2 demos, so let's see if we can sneak this one in there. Are there chaos engineering tools for serverless, not container-based, focus on open source? Or not, if there's just not.
I mean, trying to remember, there are a couple projects out there. They're pretty immature as far as I know. A lot of the stuff that you're going to be doing with serverless ends up being instrumenting your code with it. So for example, like Gremlin, we've got what we call ALFI, which is application level fault injection. And I know there's a bunch of other projects depending on what language you're using. And basically, they'll do things like inserting latency as your code runs to make your code slower, or if you're doing any sort of like API calls from your code, they can mess with the network there or throw errors. But yeah, really a lot of it depends on what language, what frameworks you're using. I think there's like Chaos Monkey for Spring Boot is one of them. Things like that.
Yeah.
Indeed, yeah. And indeed, for serverless, I think, I don't know, Microsoft also has their Azure Geo Studio. It's built upon the framework of, let's say, Geo's Toolkit. So there's Azure model product built on Azure Toolkit that's now embedded in the Azure DevOps. And for sure, if you are running Azure serverless, then this will also be there.
Awesome.
Yeah, I think we are just starting with serverless, so I think that that will evolve also. But any kind of logic that you run within those functions, you may want to inject failures. So that's just another code delivery that you want to, yeah.
Yeah. All right, awesome. I'm gonna take a look. I don't think we have any other questions right now. So I know a couple of you have demos prepped. If you all want to flip a coin and figure out which of you want to go first and show off some chaos tooling.
Let's start with Gremlin.
All right. Since we've been talking about Gremlin a bunch, sure, why not?
Yeah.
Go ahead and share screen. I can't do this. Let's share that. Can you all see that screen?
Yes.
Yeah.
All right. So this is Gremlin when you log in. This is what it looks like. We try to make things easy for you. So you'll log in. There's a bunch of recommended stuff for you. So it helps you out if you don't know what you're doing or where to start. We've got a bunch of things on the side. I did mention earlier, someone had asked about like discovering what to attack or where to start. So this is our new service discovery. Basically, it's gone out there and it's looked at in my demo application and gone and found all of the services that I've got. It's pulling in a bunch of tags for me. So this one, there's just a bunch of metadata that's going to pull. If you're running in AWS or Azure or any of those where you've got those tags, it'll pull those in. But I can click into that and see a little bit more about it. And we've started to add a lot more features around helping you track what's going on, so you can keep up to date and know how reliable your system is, or at least how often you're testing it and running things. So you can add links to dashboards, runbooks, owners, and help get things there. I can flip over to targets and we can see that I've got a couple deployments for this. So I can click attack target. This is going to pop me into the attack screen. So basically it's the same thing if I wanted to run an infrastructure attack or anything else. Basically the same interface, but it allows me to choose that service. This one, because it's running in Kubernetes, it's going to allow me to select the cluster, and we have the ability to hone in on namespaces. So part of this is because a lot of folks are using namespaces to separate out teams, or things like prod versus staging on the same cluster. And then we can set our targets. So right now, because I had already said add service, it's got that pre-selected. But if I wanted to target anything else, I could do that. As I scroll down, I choose my attack. So we've got 11 different attacks. Resources are the common things: CPU, disk, IO, and memory. State is going to be things like killing a process or shutting down, in this case, the containers or the host. And then if you had this on the host level, like infrastructure, like an actual service or server rather, you could do time travel, which is skewing the system clock. And then we've got network. So network is black hole, essentially cutting something off from the network, DNS, latency, or packet loss. So it'd be able to choose one of these. For example, I could say black hole this service. It's going to provide a bunch of additional configuration parameters that I can set. But basically from there, I could say unleash Gremlin, and it's going to go out there. And what's going on now is our backplane is communicating out to the agents that are sitting within this Kubernetes cluster. They'll get the message that they need to attack and what they need to attack and all the parameters of running that. And then that'll actually run. The nice thing about this is because they're all communicating back to the backplane, if at any point they lose communication or something goes wrong, they're going to immediately just start that rollback. So that's basically how it works. So a bunch of other features that we've got, like scheduling and obviously an API, so you can start to automate things, but pretty straightforward.
Nice.
That was awesome. Thanks. Thank you, Jason.
Yeah.
Thanks.
Who's
Great.
next?
Yeah, so I will share my screen. Share screen. Two. Hopefully you see my screen now. So let's start. I've prepared a really short demo. As mentioned, I also wanted to do a Gremlin demo, but then I saw Jason his name, so I thought I will do Litmus. Litmus is also a tool which is part of the CNCF Cloud Native landscape. It's part of the observability analysis section, Chaos engineering tools, and it's a sandbox project, just like Chaos Mesh. There's a URL here. I will share it in the comments later. And this is what I'm going to show you. What I've did is I've deployed the operator, which is already there. It's an operator that creates some CRDs, and it's Litmus Chaos. Nice thing of Litmus is that it uses a hub, a Chaos hub with all predefined experiments which you can use. So it's, let's say, a quick start to start with it, but be aware. First, think about your experiments. Besides that, there are three main components. CRDs, these are the engines itself, Chaos Runner, the experiments, and in the end, the results. All visible using kubectl. So that's the way how I like it. And yeah, for this, I created a demo app called Elmo. And we see Elmo running now, and it's still there. And I just do Elmo because all these agile people, when you talk too much, they call Elmo. So that's why I now burn Elmo. So let's have a look. So we'll run my test if it's still up. And as I told you before, we have some custom CRDs there. So to run and execute this experiment, you have to create a job. So this job, when you look at it, this is really making use of the Kubernetes manifest, CRD, and you will, let's say, configure it for a certain app deployment. For this one, I've configured it for Elmo. And in this, I've added some experiments. So with some comments. So configuration parameters like how long does it take? What's the interval? And is there a force needed? Do we have to execute force? So I put it off. The nice thing is we can just apply this manifest and it will execute. The most important thing you don't have to forget is the service account. So for this, I have created a pod service account, which is there, and which I'm using. So looking at the current
Hey, Arnold,
scenario,
can you zoom in on that text a little bit just so we can see it a little better?
in.
Yeah, just make it a little
zoom in.
bigger, or just change the text size.
Not there. Zoom in.
Maybe a couple more times just so that where you're looking is.
Yeah.
Yeah. Thank you.
Okay. So, oh, got a nice thing. I will now apply the experiment job. And here you will see the results. And damn, my site is getting hit, and I see that it's most times there. Sometimes it's blocked. So yeah, what does it bring? It really helps me, and this is a really simple example how to give you the ID to work with this flow and to get the ID, what went wrong. So looking at our pods, for example, we see that it's killed. And then after a while, it's running again. But what we have learned is that we have to improve our replicas. And this is a very simple demo, but it shows how simple and effective you can test these things. Because now I've increased it, and of course, I now see 3 Elmos running. And if we fly it again, everything is still running. So for this demo, I really took one example. This is just, for me, the let's say the building this custom container was more work than setting up the whole tool and doing this demo for you. But you can also select all the other demos that you have. So I really hope that you liked it, and it really helps to see what's all possible with tools that are available and how you can use them. And sorry about Elmo. Yeah.
Nice, that was fun.
All right.
Yeah.
All right. That was awesome. Thank you so much from both of you. So as we're about to head off, what's next? What's going to be next for Chaos Engineering?
So,
no pressure.
What's
Predict the
next?
future.
So yeah, for me, what's next? What I think, but I'm not a guru. So what I think, it's getting more common. You see that more people are using it, get used to the principles. It took a while because 2015, it's 6 years ago. So, but it's now more common, and it's now also getting more a shift left to the performance tester. So within my team, I also have a performance testing guy, and we want to make this part of, let's say, the performance testing, because it's also important part of that side. Besides that, I think it's good to combine these things with monitoring. And one of the other things what I like, and that's is, let's say, a sort of like what we have with the tracing, the open telemetry, that there will be an open GAOS or a GAOS entry in the open telemetry part, so that it's standardized over the industry, because now we have all custom agents. Like in the old days, we had all APM tools with all their own libraries to put in, like what we have, Dynatrace, IBM, AppDynamics. Would be great to have one library that can be used by the programmers and that can be added to Gremlin or the tool that I just shown, or even Yoast Monkey. That would be awesome. But I think that will take some years.
Yeah, I'd agree that, we're getting there. As Arnold mentioned, just getting broader adoption. So we've already mentioned Azure has Chaos Studio that they just announced, and it's currently in a closed beta, but they're planning to launch or open that up this year. AWS has their failure injection simulator, which I know Adrian Hornsby and a bunch of other folks have been working on for a while. So as this happens more and more, we're starting to see there's going to be more tools available. There's going to be more support for those managed services. And I think, as Arnold mentioned, that ultimately will lead towards some sort of standardization, right? If I'm using an open source tool in the same way that I can count on it emitting metrics thanks to things like open telemetry, hopefully they'll have something like Open Chaos where it publishes, these are the ways that it can fail and here's how to test it.
Nice. I think also we are working on making chaos as part of this software development lifecycle and really just making it almost automatic and visible for the service owners, just to make it run all the time or very regularly. And also we are, I think the idea of like going beyond the chaos and just like doing any kind of infrastructure experiment is important. So I think we will propagate that idea. We'll talk about it more in the next few months.
All right. Awesome. Well, thank you all for joining us today. And for everyone listening, the recording will be made available. So feel free to pass it along to anyone who couldn't make it or is just interested about chaos engineering in general. And if you tune in on the 12th of May, same time, 8 p.m. Central European time, the topic is going to be open gaming and open source game development with M. Laser Walker, who is a cloud advocate at Microsoft, and Mark Mandel, developer advocate for Google Cloud for Gamers. Spread the word. It's been wonderful speaking with y'all today.
Thank you. That was fun.
Thanks.
Yeah, thanks.